And with us, we have J.Rosenbaum, who's a Melbourne-based AI artist and researcher working in 3D modeling, artificial intelligence, and extended reality technologies. They have a PhD from RMIT University, studying AI perception of genders and the nature of AI-generated art and human hands behind the process that engender the bias. And today, they are going to give us a talk on AI perceptions of gender. I'll hand it over to you.
Thank you so much. Yep. Just wait for the slides to pop, but yeah. So hi everyone. I'm so excited to be here today. I love Pycon. My name is J.Rosenbaum, and I'm an AI artist and researcher, and I'm a lecturer in critical AI at RMIT School of Design. The term AI artist has become a really loaded term lately. When I first started working with machine learning art nearly a decade ago, it was easier to say AI artist than machine learning artist. But nobody knew what machine learning meant. An AI artist was sort of a sci-fi, fancy, fun marketing term. And now, of course, it evokes ideas of shortcuts and plagiarism and creative theft. And I don't really like being associated with that anymore. But I do still use the term, after a lot of internal wrangling, I do still use the term AI artist. Sometimes with a little bit of irony. And because my practice deeply engages with AI systems, not just as tools, but as objects of critique and study. Today, I'm going to talk about my research and the art I created during my PhD, which explored AI perceptions of gender. My focus was on how AI interprets and represents gender, challenging the binary frameworks that dominate machine learning and expanding them beyond biological essentialism. Gender is vast, it's deeply personal. It's so much more than just anatomy or a checkbox on a form. Through my work, I've asked questions like, why do AI systems perceive gender, and how do they qualify gender in the images that they generate? If we create a biased data set and slowly debias it by introducing new data, how will the generated images be affected? And what are the implications for visual representation present in generative images of people? And a lot of these questions are still ongoing today. Like, the PhD is finished, but I'm still finding myself coming back to these questions over and over again. I trained a biased neural network, and I sought to see if I could add data to change its biases and what it looks like if I did. I examined existing systems and looked at how they explore gender and what they see when presented with gender beyond the binary. And I explored a new way of looking at gender classification completely by assigning people a custom mixed color. If you were at Pycon last year, you might have caught my talk on that one. My first project, Set in Stone, began with exploring whether we can change these biases in a biased system. People often talk about the way to fix a biased system is to add more data. So I went, okay, let's start from that point. Let's add more data. Let's change the narrative. So I worked with generative adversarial networks, GANs, using techniques like transfer learning, where you retrain a neural network after it's already been trained, and what I liked to call disruption training, where I would just add in new data throughout the training process while it was still training. And that approach really allowed me to see whether a GAN could unlearn its original biases and adapt to new representation. Sorry, masks make you dry. The title comes from a metaphor that I kept coming back to, the way AI systems encode bias as if carving it in stone. So I started with DC GAN and ProGAN models, which generate images by learning patterns from a training data set. My goal was to see if I could reshape that stone by injecting data that defied stereotypes. I created 3D rendered faces from my data set, representing masculine, feminine, and non-binary traits with classical marble aesthetics, leaning into that set-in-stone metaphor. I tried to make them as racially diverse as possible. I created an animation with 3D rotation and used all the stills as the training data set in this 3D rendered environment. So for this project, I first trained a series of DC GANs, or deep convolutional generative adversarial networks, with my data set of masculine faces. Over time, once it was well and truly biased, I introduced feminine faces, and then faces representing more non-binary aesthetics. Images emphasizing external markers of gender expression, like brightly colored hair and makeup. These elements were chosen to highlight how gender minorities often communicate their gender and highlight how we see our identity visually. Because non-binary people don't always, look non-binary. So how do you tell that to a computer? So it's a little on the nose, the coloured hair and makeup. It's a bit of a stereotype, but sometimes you need to be a little literal. And it worked really well for that breaking of the stone metaphor. As new data entered the system, the generative outputs shifted. Initially, the GAN's output reflected the rigid binary ideas of gender, but as the training progressed, these boundaries softened. Vibrant colours emerge and the works take on a more fluid and joyful take on gender. However, even as the GAN integrated the new data, I noticed a tendency to revert to its original masculine bias over time. Increasing the volume of non-binary and feminine-coded data helped to counteract that reversion, but the model never truly forgot its initial biases. Switching to a pro-GAN, or progressive growing GAN, yielded smoother transitions. The technique used to debias was the key observation here, as I had to create directories filled with the same masculine data set. Initially, it's a labeled GAN, so I needed to create the labeled data sets filled all with the same data and then change them up over time. And then I replaced the data gradually with more diverse images. This was a fitting metaphor for how some genders need to make room for the representation of others. By gradually replacing older datasets with newer images, I observed more seamless debiasing. The ProGAN created fewer artifacts and seemed better at integrating diverse representations without defaulting to its original biases. The resulting visuals were presented as mosaics, wallpapers, and looping videos. From afar, they appear as cohesive portraits, but up close, viewers could see that the hundreds of, and thousands sometimes, of smaller images that made up each face. These layers reflected the idea that gender is shaped by accumulated experiences and self-expression over time. Through Set in Stone, I learned that while debiasing again is possible, it's not always straightforward. The architecture of the neural network has to play a part in how successfully it can adapt to the new data. And much like people, AI systems can carry their history with them. Even as they evolve, the large-scale mosaics show not only the AI aesthetics and the debiasing of the neural network, but created a dialogue about how we are the sum of our experiences, not just what you see on the surface. In the looping video, this one, the face continually zooms into one square of many in the mosaic, which then shifts and changes, developing into a new face which is zoomed into again. Each face exists because of all the faces that surround it, helping it become. I show here not only the shift caused by debiasing and AI techniques, but also the experience of being transgender, the exploration of gender as observance, as expression, as experience. This concept of gender as experience is one I return to in my gender tapestry work, discussing gender as a highly personal lived experience that is unique to every individual. The second project in my PhD was an analysis of existing systems in a complex loop of AI architectures. If you've ever played a game of telephone, you know how a message changes when it's passed along the chain, or Telestrations, the board game. I wanted to see what would happen if I turned that idea into an AI experiment. What happens when I link a bunch of different AI systems together and observe their output? So Frankenstein's telephone explored how AI systems gender images, revealing the biases embedded in their datasets. This project works like a game of telephone, using a chain of AI systems that pass an image and its interpretation from one to the next. The process started with ATTN-GAN, the very first text-to-image generator, that created an image based on a user's input prompt. That image was segmented by Deep Lab, breaking it into labeled regions, like sky, person, tree. And the segmented image was then reimagined by Spade Coco, which reconstructed it as a new image. And finally, Im2Text generated a caption for the final image. So that's probably very unreadable, but that's okay because we've got a readable version coming up. Oh. This chain highlighted how each system introduced new layers of interpretation, distortion, and bias. So this one, the prompt, a woman with a dog on a leash, it's now segmented the dog as partly a person. And it's been a bit interesting, which has then turned into this version, this further version, which has... these are very chaotic images. These are very early generative AI systems. They're not what we're used to now. But then image to text captioned it as a man riding a skateboard down a street. So, this chain highlighted how each system introduces new layers of interpretation, distortion, and bias. For example, Deep Lab's segmentation labelled all humans simply as person, removing gender entirely. Yet, by the final stage, gendered language had appeared in the captions again. Binary words like man or woman would emerge based on contextual clues like clothing or background elements. I traced this bias back to the human-generated captions in the training datasets. These captions frequently gendered people even when their faces weren't visible or when the person in question appeared abstracted or incomplete. This pointed to the assumptions of the dataset's human annotators, many of whom worked under vague instructions through mass labour platforms like Amazon Mechanical Turk. There's little to no training in situations like these, just a short series of instructions. It strikes me that a specialist could be hired to specify clearer instructions to avoid gendered outcomes, like I observed in the dataset, and especially the occasional sexist or racist outcomes I observed in the dataset. The dataset often would have value judgments. A very beautiful woman doing this, and then if it was a man, it was a man. Whereas gender actually, if one was just a hand and they went, oh, that's a woman's hand. It's like, it's a black and white hand. It's barely in focus. Who knows whose hand that is? Come on. We don't need to gender these things. But that gendering, that bias, that came through. Those assumptions all came through in the work. The visual outputs of Frankenstein's telephone are surreal and unsettling. Pale, fleshy figures with exaggerated alien features, these dreamlike blobs reflect the dataset's lack of grounding in real human anatomy and raise questions about how machines create images and perceive images around gender. For me, the work became a metaphor for how transgender and gender non-conforming people are often perceived. Misunderstood, distorted by societal expectations. An interactive version of this project let users upload their own images to see how the AI chain reinterpreted them, and that went about as well as you could expect. Many participants were surprised, and some were quite vociferously upset by the results, particularly when the system misgendered them. The complaints I got were all from cisgender men. White men, I should say. What a surprise! This sparked conversations about how machines and people perceive identity and those very real harms caused by assumptions. This project, unfortunately, is no longer online because the systems that were being hosted have been taken offline in favour of generative AI systems. So I need to go back into the code, rehost these on a different platform, set them up, and reinitialize the project. And I also want to take it into generative AI systems and redevelop it to see, have these systems evolved? Have they updated? The images are better, but are these biases in the chain, do they still come out? Do the machines still misgender people? Do the systems still observe a new gender? So that's what I'd love to contrast with the earlier versions. See what developments, if any, have happened. I've also spun this research into a series of image generations across multiple stages of generative AI systems to see how they all interpret the same prompt. This project is ongoing and may never really have an end date as new versions keep coming out, but the biases are very, very clear. I should explain that my methodology here was that it was the middle of winter and I was very cold. And I think it was during lockdown as well, so I wanted to be at the beach. This is a legitimate methodology. So just in looking at generative images of non-binary people, I've noticed the same trends. Every person is young. Of course, they're all gorgeous. Almost all of them have the short, fairy hair, pale skin, and most are femme. Despite the many non-binary people I know with beards, I've actually never seen any on a generated non-binary person without specifically asking. Actually, apart from the age, they all tend to look very similar, which is great for all of the people who fit in that box, I guess. But what about non-binary people of color? What about high femme or high mask non-binary people? It's so very hard to get a non-white, non-binary person that even if I explicitly state an ethnicity, it still struggles. The Eurocentric biases of these systems have always been really strong, but for non-binary representation, it's an almost impassable barrier. I'm taking similar directions in some of my new work to explore how image-to-text systems view a pixelated image of a person and reinterpret it as a new image. This shows the biases of the system very clearly, and by making it personal, shows how these systems average out features and remove individuality through their biased data. I actually really like this image, though. I didn't save the caption, though. I wasn't wild. The captions are quite horrible. They're through clip, but I really actually quite liked that result. I felt very validated. Sometimes these systems don't suck. No, they do. They all suck. The final project in my PhD, Gender Tapestry, brought together the insights from my earlier works into a unified piece. This interactive project aimed to reframe gender classification as a spectrum rather than as a binary, using a custom classifier that assigned each participant a unique colour. The data set for this work was mostly generated. It felt less problematic to use generated images of people, and originally I had an even spread across genders. However, I found that the colour results in that case were very, very limited. I actually needed to bias the results, bias the data set, which really surprised me. That was a crazy thing. I've been fighting bias my whole machine learning life, and now you're telling me I need to put in bias, but the data didn't lie on that front. So I actually biased the data set in line with current representational data. I still kept it as diverse as I possibly could, but and I sorted them into 6 different pronoun categories. Users upload an image of their face, which is analysed by a multi-label classifier trained on these pronoun-based data sets. Instead of assigning a gender, the classifier outputs percentages that are then added together to create an RGB value. These values were used to generate a custom colour, which represented the user's unique experience of gender. What I particularly enjoyed here was that by taking 6 and turning it into 3 by adding those disparate parts together, I created some randomness. And then if the number went over 255, the modulo operator kicked in and brought the number back around, which again increased that randomness. So while these classifications and these colors are based on fact, they're actually all still, they're based on a scientific methodology and on proper classification, but there's still an element of, magic and weirdness and math that helps create those beautiful random effects. You can actually, it's probably still up at gendertapestry.com. The GAN won't be running, but the rest is. The user's colour and portrait were then added to a growing dataset, which was used to generate a mosaic of CAN-created faces. Over time, the mosaic became increasingly complex as more colours and images were added, illustrating that diversity of gender experience. The concept of assigning a colour to gender stem from the idea that, like colour perception, gender is subjective and deeply personal. My research revealed that we all actually see colour differently. The blue sky that I see is very different from the blue sky you see. So it's actually all a very, very subjective experience, and gender is a subjective experience. And it's all deeply personal. So while two people might have similar experiences, no two are exactly alike. This approach challenged the feasibility of gender classification by AI, emphasising that gender isn't something that can or should be reduced to a binary. Across these projects, I explored the ways AI reflects human biases and the potential for creative interventions to challenge those biases. Some of my findings include, shocker, bias is deeply embedded in datasets. Who knew? Even when AI systems are trained on neutral data, the assumptions of their creators can shape their outputs. In the paper, biased datasets are not enough. Results like classifiers would classify an image as a woman if a person appeared in a kitchen, because photographs of women were more common in kitchens than photographs of men in kitchens. Just a small example there of some, systemic bias there. AI can evolve, but not perfectly. While new data can shift a model's perspective, it often retains traces of its original biases, much like humans do. Representation matters. Expanding datasets to include more diverse identities is crucial for creating more equitable systems, but it's only part of the solution. Through my practice, I hope to highlight not only the limitations of AI, but also its potential as a medium for reflection, critique, and growth. AI systems may never fully compute what gender means, but by questioning their outputs and our own biases, we can move toward a more inclusive future. The best time to start is yesterday. We know that, but the next best time is now, today. So initially, humans are told how to perceive gender. They learn what gender is from their parents, teachers, and peers. They grow and learn. They learn to perceive gender how they want to perceive it. They research, or they don't. They learn and listen, and their understanding of the concept of gender grows. Similarly, machines are taught how to perceive gender by humans. They are shown images and told that these images correspond to genders. An AI will not update its definitions on gender unless instructed to. It will not change its perspective or enhance its understanding unless it is specifically retrained. It can only do as its instructions permit. It then falls to the people training the AI and constructing the datasets to ensure that it's trained without bias. A computer itself has no inherent biases. It's only taught bias as it learns and incorporates biased data and algorithms. The people working with the AI, therefore, need to understand the potential for bias and the inherent issues in facial classification tasks, including gender classification, especially gender classification. People are naturally, consciously or unconsciously biased, and their inherent biases creep into their work. We can help subvert bias by being self-aware of our own biases and our own issues. Gender is an ever-evolving social construct informed by experience and upbringing. Similarly, AI is an ever-evolving machine construct with human-supplied inputs that could be kind of equated to a form of experience and upbringing. Raising an equitable AI requires the voices of many and the intention to listen when issues are exposed. As we are currently in the nascent stages of understanding AI, now is the best time to explore how they interrelate. Untangling the convergence of machine learning and social change is a key requirement right now, especially as AI development is so rapid. The time is ripe to merge these developments and to realize we cannot train AI in the outdated social mores of the past, but rather think ahead to a new stage of development and understanding of ourselves and our AI. We need to be aware and critical of our biases, examining the datasets we create and the methods we use to train AI. This vigilance isn't just about fairness. It's about creating systems that reflect our humanity in its fullness, not just a narrow, biased sliver of it. And that brings me to why this work matters. It's not just about AI and datasets, it's about us. It's about how we define ourselves and each other. It's about how we interact with technology and how those interactions shape our future. If we allow AI to learn from our worst habits, our biases, prejudices, and assumptions, it will replicate and reinforce them in ways we might not even notice until it's too late. But if we teach AI to recognize the diversity and fluidity of human identity, if we build systems that acknowledge and celebrate the complexity of gender, we're not just making better AI, we're creating a better reflection of a better world, one that sees and values everyone. Thank you.